Good morning to all. I am Smati. In this video, we are going to see about selective repeat ARQ in sliding window protocol. Before going to selective repeat protocol, we will first know about what is sliding window protocol. Sliding window protocol is used for controlling the flow of data between any two devices. That is, that flow of control is flow of transmission is controlled between the sender and the receiver. Here the main advantage is that the data is sent consistently and effectively, allowing many packets to be sent before requiring an acknowledgement for the first frame. Maximizing the use of available bandwidth is the greatest advantage of this sliding window protocol. This sliding window protocol is a data link layer protocol that is useful in sequential and reliable delivery of data frames. Using this sliding window protocol, the sender can send multiple frames at a time. When the receiver receives the frame, it sends back an acknowledgement to the sender. The acknowledgement lets the sender know that the particular frame is received by the receiver. The sliding window protocol uses the mechanism of sequence number to arrange the frames in order if the frame was retransmitted. The sequence number also helps the receiver to identify the lost or damaged packet. In sliding window protocol, we use an imaginary box called window to hold the frames at the sender's end and the receiver's end. The window on the sender side covers the sequence of data packets that are sent. On the other hand, the window on the receiver side covers the sequence of packets that are to be received. The sender window size is represented using WX and the receiver window size is represented using WR. The sliding window protocol uses the full duplex for data frame transmission. The sliding window protocol is also used as the TCP, that is transmission control protocol. There are two types of sliding window protocol, that is go back N ARQ and selective repeat ARQ. In this video, we are going to see about selective repeat ARQ. In my previous video, I have discussed about go back N ARQ protocol. Selective repeat protocol is also known as selective repeat automatic repeat request. It is a data link layer protocol which uses the mechanism of sliding window technique for reliable data frame delivery. Only erroneous or lost frames are retransmitted in this case, while the good frames are received and buffered. Selective repeat ARQ is used in data link layer for error detection and control. The sender sends the several frames specified by the window size in the selective repeat without waiting for the individual acknowledgement from the receiver, as in go back N ARQ. In selective repeat ARQ, we only resend the data frames that are damaged or lost. If any frame is lost or damaged, then the receiver sends the negative acknowledgement to the sender and the frame is correctly received. It sends back the acknowledgement. The sender sets the timer for each frame, so whenever the timer is over and the sender has not received any acknowledgement, then the sender knows that the particular frame is either lost or damaged. As the sender needs to wait for the timer to expire before retransmission, we use the negative acknowledgement NAC. The acknowledgement and the negative acknowledgement have the sequence number of the frame that helps the sender to identify the last frame. Important points regarding selective repeat. The receiver has the capability of sorting the frames present in the memory buffer using the sequence number. The sender must be capable enough to search for the last frame for which the negative acknowledgement has been received. The size of the sender window is 2 power m-1, where m is the number of bits used in the header of the packet to express the packet sequence number. The window size of the receiver is the same as that of the sender. In selective repeat protocol, the efficiency is n divided by 1 plus 2 into a, where a is the ratio of propagation delay versus the transmission delay, and n is the number of packets sent. It is efficient as only the last or broken packets need transmission. Working of selective repeat request. In selective repeat request, only the erroneous or last frames are retransmitted, while the correct frames are received and buffered. While keeping track of the sequence number, the receivers buffer the frames in the memory and sends negative acknowledgement for only the missing or damaged frame. The sender will send or retransmit the packet for which negative acknowledgement is received. Here is an example which will clearly demonstrate the working of selective repeat request. Suppose, consider that there is a sender and a receiver, and there are 11 frames to be sent from the sender to the receiver, and they are numbered as 0, 1, 2, 3 to 10. The size of the window n decides the sequence number of the frame. For better understanding, we have taken here the running numbers. Step 1. Let us consider the sender's window size to be 4, which means that the sender can send 4 frames before expecting any acknowledgement from the first frame, which is 0. So, here the window size is 4, so the sender can send 4 frames, that is 0 to 3, continuously. Multiple frames can be sent, that is 4 frames can be sent without receiving any acknowledgement from the receiver. Step 2. Continuously 0 to 3 frames are sent to the receiver without receiving any acknowledgement. After sending 4 frames, it waits for the acknowledgement of the 0th frame. After the acknowledgement of the 0th frame is received, now the window moves from 0 to 1, 2, 3 and 4. As the window size is 4, the window moves gradually to the right side, that is 1, 2, 3 and 4. Next, the fourth frame is sent, as we have received the acknowledgement for 0th frame. This 0 indicates that the acknowledgement has been received, and this numbers within this window indicates that we have not received the acknowledgement, and this indicates the frames to be transmitted. So, this sliding window moves gradually after the receiving the acknowledgement of the frames being sent. Now, here we have received the acknowledgement for the first frame also. So, the sliding window will move from 1 to 5. So after that, 2, 3, 4 and 5, fifth frame will also be transmitted as the window size is 4. Fifth frame is also being transmitted. Now, we have to receive the acknowledgement for the second frame, but here the acknowledgement for the second frame is being lost. In this case, we will not receive the acknowledgement for the second frame. Hence, we have to retransmit the frame. Here, the receiver will send the negative acknowledgement for frame 2. So, the sender will retransmit frame 2 alone. Here we have received the negative acknowledgement for frame 2. So it will retransmit frame 2 alone, whereas in go back and it will retransmit 2, 3, 4 and 5. But here only the last frame, that is the negative acknowledgement frame received for frame number 2 is alone retransmitted here. This 4 and 5 will be kept in the buffer, which will be taken as usual. This is called as selective repeat request. In this procedure, the main difference between go back and selective repeat is here the last frame alone is being retransmitted. It is selectively selected and it is retransmitted again. This is after receiving the negative acknowledgement. Advantages of selective repeat is it is used for efficient data transmission. Here only the last or damaged frame is being sent, and it saves the bandwidth and improves the efficiency. It is minimizing the congestion and faster recovery is done, optimizing the network utilization, and resources are utilized more effectively. And this protocol enhances data reliability by correcting the specific errors, ensuring accurate data delivery. Advantages of selective repeat protocol: it supports high error rates and it is adaptive, that is the protocol adjusts to varying network conditions. Higher throughput due to its targeted retransmission. The protocol maintains a higher throughput than other strategies like go backend. Minimal latency: it reduces latency by selectively resending only the required frames instead of waiting for a larger window of frames to be acknowledged. Efficient for large windows, particularly useful in scenarios where larger window sizes are needed, as it avoids unnecessary retransmissions of correct frames. Disadvantages: it is increased complexity. Selective repeat protocol adds complexity to both sender and receiver sides, requiring additional logic and mechanism to manage individual acknowledgement and retransmission. Higher overhead: maintaining a sliding window for each unacknowledged packets increases overhead, consuming more memory and processing resources. Out of order delivery: selective repeat can result in out of order delivery of packets at the receiver due to potential variation in transmission times and acknowledgement. Retransmission overhead: in case of packet loss, selective repeat may trigger unnecessary retransmission of individual lost packet, leading to redundant data transmission. Increased delay: protocols complexity can introduce delays in processing acknowledgement and handling retransmission, potentially affecting real-time application. Synchronization dependency: the protocol relies on synchronized timer and acknowledgement, making it susceptible to disruptions in synchronization that could lead to inefficient retransmission. These are all the requirements for error control, that is reliability, efficiency, scalability, error detection and correction, adaptability, minimal impact, security, compatibility. These are all the terminologies used in sliding window protocol. Conclusion: this protocol stands as a cornerstone in modern data communication and networking. Through its selective retransmission mechanism, selective repeat ARQ ensures reliability and efficiency of data transmission in the face of packet loss and errors. Thank you.